Welcome back to part 2 of the Rockwell project. In this episode, we'll be tearing apart a lot of the fiddly bits of the vertical component. So the fine feed control, the head rotation mechanism, the pulleys inside the head itself, which were remarkably difficult to get out, as you'll see later. But before we get too far into it, I did want to address one point. On the last episode, I caught some flack because I labeled this as a rebuild video. And rebuild has a very specific connotation when it comes to machining, which I didn't quite realize at the time. It very much implies that you're going to be scraping ways and doing realignment and generally getting the machine back to exactly how it was when it came out of the factory. Now, I had grand ambitions when I first started this project. I wanted to do stuff like scraping the ways and realigning, but once I got it torn apart, or at least halfway torn apart, I reassessed my skill in the project and decided to stick with a clean and repaint so I didn't mess anything up. So folks who said this was not a rebuild were 100% correct. It is, in fact, a clean and repaint. That said, cleaning has been immensely satisfying. So as you can see here, these are the bearings from the spindle, which were feeling a little rough when I first got the mill. As it turns out, the grease is not completely dried up as I feared, but it is in a state of jello-y consistency. So it's pretty sludgy, and a lot of it's worked its way out of the bearing races and just kind of sitting on top of the bearing itself. So I'm happy that I did pull this apart so I could clean this out and re-grease it. If you look closely at the grease too, there's a noticeable amount of just kind of grit and grime, which are probably not great for the bearings either. This head rotation mechanism was interesting to pull off. As you'll see in a second, the worm gear that drives the mechanism is steel, but the worm wheel that's driven by the worm is in aluminum. I'm not really sure why aluminum was chosen here, being a softer metal. If there's any side load on the head while cutting, it seems like you could shear off some of the teeth on the worm wheel. Maybe the worm wheel was chosen as aluminum so that it's a replaceable part. You know, if something goes wrong, you can shear off a few teeth and then replace it. I'm not really sure. If someone knows, I would love to hear the answer to it. It just seems like an interesting choice where you don't want a soft metal being used. My worm wheel was in reasonably good shape. None of the teeth were sheared off or in bad condition, but there was a certain amount of deformation on different teeths and on the edges, which I went through with a small file and tidied up. I don't think this was critical in any regards because the metal was being pushed out of the way of the worm gear, but I figured it couldn't hurt to do some cleanup while I was there. We've got the head unit mostly disassembled, but this pulley section is stuck. So this is stuck inside the head and we can't get it out. And the reason for it is there's a lock nut right here, which is holding on to this piece right here, which that is the hub for the spindle assembly. And this lock nut, you can see down here, part 33. This lock nut's basically holding the spindle onto the bottom of the pulley, which is locking both the top and the bottom pulley pieces together. And that's important because we can't pull this thing out. It's too big to come out the top here. And we can't move it out the side because this spindle brake is in the way and runs into the side. And the spindle brake only comes out if we remove this top portion of the pulley. So to do that, we basically have to pull off the lock nut first so that we can disassemble it and then get the spindle brake off and then pull all the pieces out individually. At least I think that's what we're supposed to do. So this is not an easy proposition because this lock nut's in kind of an awkward location. So most people that have this mill will grab a socket of the appropriate size, like so, and essentially grind away the socket and leave the 4 tabs. So that was my plan because other people have done it. It seems to work well. But my socket in question here is chromoly, and this stuff is just hard as nails.
And once I started looking at grinding it or using a cutoff wheel, it looked like a real pain in the ass, to be perfectly honest. So I went back to the store and looked around and found this. So this is a, well, I think it's for 4-wheel drive lock nuts or whatever. I don't know. But it basically, it fits my lock nut mostly. It's a little big, so there's a little bit of play, which I'm somewhat concerned about. We don't want to strip out the lock nut indentations. But I'm hoping that this works tight enough. If not, I was going to pound in the tabs at a bit of an angle and see if that gives it a tighter fit. And then hopefully this will let us pull off the lock nut. Otherwise, we'll have to go back to plan A, which was this. I've got it soaking in penetrating oil for the last couple nights, so hopefully it's loosened up at least a little bit and won't put up too much of a fight. So, see how it goes. All right, that's a tighter fit than I was expecting. How about that? Oh dear, well, I guess it didn't really fit all that well, did it? That's not great. I might see about finding a replacement lock nut for this. We'll see how bad it is once I get it popped off. Alright, so here's the lock nut, and the damage done is, well, it's not great. You can see there. Let me grab a screwdriver. So that's where it got stuck on one side, so that's not fantastic. That I could probably file out. It's not a big cut. Same thing here. That could probably be filed away. This one's a bit more gruesome. There's still quite a bit of clearance there. This one is pretty ugly too. I don't know. That's looking pretty rough on that side right there. I would be worried about getting this seated again and then not be able to get it out because it's stripped. Well, I don't know. We'll see. I might just replace that. I'm sure these are not terribly expensive or hard to find. But we did get it off, so that's pretty cool. So now I just need to get this lock washer. I'm not really sure what this is called, to be honest. Let's get a pair of pliers. There we go. Okay, now in there are 2 bearings, which are holding this spindle against, well, the spindle holder against the rest of these pulleys. So I think I should be able to knock this straight down, well, gently tap it out, not knock, pull out the bearings, and then disassemble this whole pulley contraption.
So obviously I'm struggling at this point. I know what I need to do. I need to get that spindle pulley hub in the center out somehow. I was trying to find a method that didn't involve tapping or hitting it from the bottom, since that seemed liable to do damage. But as it turns out, there's just really no alternative. You just have to kind of knock it out gently from the bottom.
Oh dear, this may have been a bad idea. This was definitely a bad idea. Voila. There it is. All right, so it's the morning. I slept on this problem, and what you didn't see is last night I spent, 30 minutes messing around with this thing, trying to get it out. Despite having pulled out this top spindle bearing retainer, I still couldn't get it out. And the problem is fundamentally that this spindle brake right here, the spindle brake is too tall for this side, and the whole pulley contraption, you can't really wedge it any particular way to get it out. So I woke up and looked at it this morning and realized I'm just an idiot. What you need to do is first take the pulley and get it up onto the bottom. So you get it sitting like this, so it's out of its hole. And that'll give it just enough clearance that up here it can sit. And then you take the brake and rotate it to the back. And you can just inch it over. And once you get it far enough, you can kind of rotate and drop it down. Now that looked really easy, because it was really easy, but I swear to God, this took me forever just kind of futzing with it to figure out how to actually get it out. So you can see there's the brake lever, and it's stuck by this retaining clip, which is why we couldn't push it out before. And then this here is the brake itself. And here are the pulleys we're interested in, also held by a retaining ring.
The bearings from the upper section were in considerably better shape. They weren't nearly as grimy or gritty. They probably just don't see as much dirt. I thought about pulling apart this pulley assembly, but that monster retaining snap ring really dissuaded me after my earlier struggles. So I just decided to clean the exterior. It looked reasonably fine by itself and just leave it alone. The pulley itself, though, I scrubbed down and threw it in Evapo-Rust overnight to help knock some of the rust back. It really doesn't matter. It's just cosmetic and a part that no one will ever see because it's inside the pulley head, but Evapo-Rust is really satisfying. And finally, I'm just going to take all the paint off the head itself and come back tomorrow and scrape it all off. That's all for now. Thanks for watching.